Hello everyone. In this 8th tutorial of the series on fire and smoke with a fluid simulator in Blender 4.5, we'll see what the two types of effector object available in Blender are, namely collision and guides. As mentioned in the introductory video of this series, the PDF version of this and other episodes is available for free download at the link you'll find in the description. Effector objects are used to deflect elements of physical simulations or to influence their flow. In the scene shown on screen, the flames and smoke pass right through the pot because they don't detect it as an obstacle. To fix this problem, we need to assign a fluid component of type effector to the pot and then select collision in the dedicated menu. As you can see, there are very few parameters, and in fact most of them we already know from similar ones used with flow objects. This is the case, for example, with sampling substeps, which adds more intermediate calculations between frames. We're also familiar with the Use Effector option, similar to Use Flow, which can be animated and therefore used to enable or disable collisions at will. We also know that isPlanar is useful for geometries that have no volume or where it's not possible to define an inside and an outside. The new parameter here is surface thickness, which creates a kind of outer shell around the object. This can be useful if the simulation causes intersections between fire, smoke, and the object's surface. Playing the simulation, however, we notice that in some frames the flames still manage to pass through the object. To solve the issue, I kept the same domain resolution but ran several tests, gradually increasing the surface thickness value. With thickness set to 1, I obtained the results shown on screen. I didn't change the substeps value, since its tooltip explains that it's mainly useful with fast-moving effectors. Our object is static, so I only adjusted thickness, and this is the final result. Before moving on to guide objects, we need to clarify another point about collisions. In the scene I'm using, there's a plane emitting particles upward. To make the particles rise, I disabled gravity in the particle system settings. The emitter object is also an inflow object for the fire simulation. So I changed the flow source to particle system and specified the particle system I had created in the corresponding field. To ensure the fire particles aren't much larger and blockier than the system's particles, I increased the domain resolution. As you can see, the particles don't interact in any way with the object inside the domain. In this case, to make the fire particles bounce when they hit the object, we need to add a collision component. This type of component makes the particles bounce, but their smoke and even part of the flames will still end up inside the object. So we also need to add a fluid component of type collision effector to properly handle the fire and smoke simulation. Let's wrap up this episode by talking about effector objects of type guides. These are special objects that need to have velocity and that influence the movement of flames and smoke in the simulation. To show you an example, I've added a sphere moving along a strange trajectory inside the simulation domain. The sphere doesn't yet have any fluid component, so it has no effect on the simulation. By adding a fluid effector component and choosing guide as its type, we see some parameters that are already familiar to us, plus a couple of new ones. Among these, velocity factor will be the one we're most interested in later. Playing the simulation, we notice a slowdown in performance, but no visible effect of the object on fire or smoke. This is because using guides, which is very computationally expensive, must also be enabled at the domain level. Otherwise, it won't take effect. After enabling the guide section of the domain, I restart the simulation. It now takes much longer to calculate, so I let Blender process it and then show you the result. The outcome is already quite different from what we saw without guides, but it's not very impressive yet. To make the object's influence on the simulation stronger, I select it and test higher values for its velocity factor. This is the simulation with velocity factor set to 5. The way the smoke is dragged along becomes more noticeable. This is the simulation with velocity factor set to 20. It's clear that a guide object is not a collider, but rather a special type that disturbs and drags the elements of the simulation. There is, however, another way to influence the movement of fire and smoke, and that's by using force fields, which we'll cover in the next tutorial. That's it for this tutorial. If you enjoy my content, the best way to thank me is to subscribe to the channel and leave a like on the video. Thanks, and see you soon.